Hello and welcome to this presentation on polymorphism. This is part 1 of 2. In this episode we'll be looking at developing a foundational understanding of polymorphism, and the reason is that it is critical that you have a firm grasp of how polymorphism works and what opportunities it offers, so you can not only make use of it appropriately but also design your systems such that you make good and correct use of polymorphism. The sample code is going to be in C# throughout the session. It will be fairly simple classes to help me impart the foundational understanding of polymorphism. In part 2 we will refactor these classes in a way that makes things a little more real world. Because this topic is fairly complicated, I assume that you already have a clear understanding of encapsulation and inheritance. So I can't talk about polymorphism without inheritance, but I won't be trying to explain inheritance. I hope you have a clear understanding of inheritance before venturing into this episode. Okay, let's get started. So what I have here is just a brand new console application, and I'm going to start defining a few classes here. So the demo functioning, or the demo purpose of this the code that we're going to develop today is going to be a bunch of classes that know how to create thumbnails for different media types, such as images, videos, and audio. Of course, in this presentation we're not going to be actually extracting images from any media files per se, but the simplistic structure of a family of classes and how to use them polymorphically will be shown in this episode. So I'm going to define a class called thumbnailer base, and thumbnailer base would have a bunch of public methods. Now this typically these methods would require some incoming parameters and some return types, but for the purpose of this demo, of course, I'm keeping it simple. There'll be no incoming parameters and no return types. Okay, so here's a base class, thumbnailer base, and it has these two methods. Let's say in here all we do for now is print out the name of the class and the name of the method. We do the same for this method here. Let's change the method name. For now I'm also going to define a descendant called thumbnailer image that descends from thumbnailer base. And at this point, because the thumbnailer base class is not declaring any of these methods as virtual or abstract, this class is at this point doing nothing in addition to thumbnailer base. But let's see how this works by defining a variable of type thumbnailer base. Let's call that thumbnailer, and let's new up an instance of thumbnailer base for now. And then once we have an instance of thumbnailer base, we'll call the get metadata method, and then the get thumbnail method. All right. So I think what we expect here in our execution of this code would be pretty much as we would expect, which is we'll see thumbnailer base and thumbnailer get thumbnail, the base class. Now I'm going to change this to create an instance of our thumbnailer image. Again, at this moment in time, because the thumbnailer image is doing nothing in addition to, or has not changed anything, it simply inherits these methods, and so the net result should be the same. So I just want to make sure we're seeing that, so everyone's on the same page. As you can see here, both of the methods are calling it a thumbnailer base, even though we have an instance of thumbnailer image. Okay, so we're now going to make some changes. So what I'm going to do is I'm going to make these methods virtual. get metadata and get thumbnail. So now in our descendant class, we can override these methods. I'm going to override. Actually, what I'm going to do is leave this alone for now. So you have get metadata as a virtual method, and I can override that here. And what I'm going to do is I'm simply going to copy this in here, but change the class name, of course, to say thumbnail or image. Okay, so without making any change to the code here, I've just made a change to the class. I made the get metadata method virtual, and the thumbnail or image now implements this or overrides this method and has its own implementation. So we should see a change here now. We should see that it's calling get thumbnail or image method get metadata. What I'm going to do is change this from a breakpoint to a console.readline. Okay, so as you can see here, as expected, I think at this point, if you understand just simple inheritance, you can understand that because this method is, this class is inheriting the get metadata, overriding the get metadata method, the override is called because the instance in this case happens to be that of the thumbnail or image class. Okay. So one could also argue that the reason the get thumbnail method is not being called in the base class and not in the descendant class is that the descendant doesn't have a get thumbnail method. So, because we saw it didn't call it, so of course the observation is correct, but the reasoning is not. So let's look at now seeing what would happen if we were to define this method in the descendant class as well. So we have a get thumbnail method in the descendant. The instance we are creating is thumbnail or image. Thumbnail or image now does have these two methods. One is the override get metadata, and the other is get thumbnail. Let's see what happens this time. Oh, I should actually just change this to be thumbnail or image. We also see the compiler giving us a warning here. This is just a warning. It's not an error. But if you were to see what the warning says, it's essentially saying that if you intend to hide this method, then please use the new keyword. Right? Now in our case, we are intending to hide this method, and so we will just modify this method with a new modifier. Now, same named, by declaring a non-virtual method in a descendant that happens to have the same name as the ancestor or base class, is not an override. So if we have the same name method in the descendant as in the base class or ancestor class, this is not an override. There's no relationship whatsoever between non-virtual methods declared in the descendants and declared in the base class. Now our brain does see there's a similarity here. It's the same name, and the compiler also was giving us this warning because the compiler is saying, well, you have the same name here. Did you really mean to hide the ancestor class's method, or was it just a mistake? So by defining or adding the new modifier in this method here, I'm just going to rebuild here so you can see the compiler is now happy, which basically says the compiler, as far as the compiler is concerned, it says, well, okay, so it seems you know what you're doing. Just want to get across to you here that the compiler makes no association between two similarly named methods. As humans, we see the similarity, but the compiler doesn't care. But the compiler in this case, the C# compiler in this case, is just trying to help us and saying, well, maybe you made a mistake. So the warning doesn't imply there's something wrong. It just means that, well, you may not have intended to do this. So if you do intend to do this, then make sure you apply the new modifier to this method, which is what we've done. And I've also fixed this thumbnail image. So now let's run this again. And what you're going to see here is that even though the thumbnail or image has the get thumbnail method declared in it, we still call into the thumbnail or base and not thumbnail or image. So this is the sort of the predicament, and this is giving or leading us into sort of the mantra or rule number 1 for understanding polymorphism at the foundational level. Let's examine this now. So let's make sure we understand what's going on. We created an instance of thumbnail or image. Thumbnail or image has these two methods, get metadata and get thumbnail. Yet, when we executed this code, the get metadata was of course called on the get metadata, on the thumbnail or image class, but the get thumbnail was actually called into the base class. Let's also look at sort of breakpoint this and see what's going on here. So I'm going to put a breakpoint here as well. Let's put a breakpoint everywhere. Just follow this in the debugger. So we started, we come into get metadata. This time it comes into the thumbnail or image. Step, step, step. Come into the next line, get thumbnail, and bang, we go into our thumbnail or base. Didn't go into our thumbnail or image, even though the instance has to be a thumbnail or image. Right, so the rule number one. What is rule number one of understanding polymorphism? Non-virtual method resolution is done by the variable type. Let's digest this. Non-virtual method resolution. Method resolution, meaning the way the compiler resolves which method to call and in which class. So the resolution of trying to determine which method to call in which class, in the case of non-virtual methods, is based on the variable type, which is the type of this variable. So we're calling methods on this variable. The fact that we're calling a non-virtual method doesn't matter what the class is, what the instance is, sorry. But because this happens to be a non-virtual method, and this variable, the variable itself, is defined as thumbnail or base, it will resolve this method call to that class's this method. Non-virtual method resolution is done based on the variable type, and it is done at compile time, which means at compile time, when I hit build or compile right here, the compiler has already figured out that when it comes to making this call here, it's going to make it based on the variable type, the type of this variable. So it's going to go into thumbnail base. This has already been figured out at compile time. Okay, so rule number one, I'm going to keep saying this because it's important to understand sort of the nuances or subtle differences. Non-virtual method resolution is based on the variable type. It has nothing whatsoever to do with the instance. It's purely dependent on the type of this variable. So then how do we get the compiler to call into the get thumbnail method of the thumbnail image? Well, it is a non-virtual method. So the simple thing to do would be to change the variable type to be that of thumbnail image. So again, I'm not changing the instance, I'm just changing the variable type. Let's see what happens this time. Oops, let me just take out all the breakpoints. Or we can look at it through breakpoints. So we look at it here. We created an instance of get thumbnail image. We called get metadata. It came into the thumbnail or images get metadata. We go step, step, step. Come in here, get thumbnail. This time, the variable is typed to be that of a thumbnail or image. The method is non-virtual. The compiler resolves it to the thumbnail or images get thumbnail, and this works as we now expect. So I hope this was a bit of an eye-opener. This is key to understanding how polymorphism works, even though at this point we're looking more at the non-virtual methods. The idea is really to be able to design a system in your head. If you understand how things work without doing this trial and error business, you could virtually design a system in your head because you understand clearly how things actually work. And that's what we're trying to develop here in this episode here. Okay, so now let's look at the sort of the next variety of things. And in order to do that, I'm going to make a few changes to the classes here. So what I'm going to do is I'm going to do a few things. I'm going to introduce a few terms as well while I do this. So first I'm going to make this class abstract. And in C#, you mark a class abstract as soon as at least one method or property is abstract. So in this case, we're going to make this method abstract, which means this method has no implementation. Okay. And what I'm going to do is I'm going to have the get thumbnail itself called. Typically, what it is in order to get a thumbnail, you have to first get the metadata from the media file. Then based on that metadata, you can go extract the thumbnail from the media file. Because over here, the caller seems to know to do that in 2 steps. What I want to do is I want to change it such that when you say get thumbnail, the class itself is saying, well, I'm going to go get the metadata, potentially return something, the metadata, and then send that into the get thumbnail method here. So in other words, the get thumbnail method will have access to the metadata, but the caller just knows about calling the get thumbnail method. So I'm going to also make this protected. Okay, and so this is an abstract base class, as known as. So earlier it was just a base class, now it's an abstract base class. There's another concept, and I'm building up to this thing because there's a lot of confusion in the community with regards to interface and interfaces and all this sort of thing. And people think that something called programming to interface means two interfaces, as in something or the other in C# and Java and other languages. Whereas actually in the Golf book, they didn't even know what an interface as we know it today was. For them, the interface was the public surface of a class. And in particular, they talk about this stuff, and in my next slides, I'll quote directly from the book, verbatim from the book, how they intended for this to be done. But that's not to say you can't use interfaces. I'm just trying to say that when they say program to interface, or when they talk about the word interface, it didn't mean interfaces. It just meant the public surface of classes. Now, this specific class in C#, this would be, in other languages, this would be called an abstract base class. It's an abstract class, and at this point we know it's a base class to other family of classes. If all methods, so in C#, Java, Delphi, Python, these would be called an abstract base class. In C++ as well, this would be called an abstract base class. If this method were also abstract, I'm not wanting to do that for this demo here, but just as an example, if this method were also abstract, oops. In other words, if you define a class where all the methods are and properties, if those languages support it, are abstract, then this is in C# this would be called an abstract interface. In C# and Delphi, this would be called an abstract interface. In C++, this would be called a pure abstract interface. Okay, and again, in the Golf book, they talk about the languages they're using are Smalltalk and C++, and they very explicitly talk about the abstract or pure virtual classes. Yeah, so when they say interfaces, they mean pure virtual classes. But for our purposes, when I say interface, I just mean the public surface, whether the class is an abstract interface or it's just an abstract base class, the public surface. So in this case, this method is the public surface of this class. Okay, so our base class is now an abstract base class. It doesn't have to be, but for the sake of this demo, I'm making that. And I'm going to remove this get thumbnail method. I don't want to have this here. So in other words, descendants will just override the get metadata method. And let me redeclare or define another class here. Let's call this thumbnailer video. Okay, so we have a situation where a non-virtual method in a base class is calling into a virtual method here, and then it does whatever it needs to do. In other words, this is supposed to be the sort of implementation of the get thumbnail method. Okay. Now, in order to make things a little clearer, I'm going to make a little more refactoring, do a little more of refactoring here in this project, just so it's clearer. The idea is that I want to extract away this the creation of this class, and there's a reason for that, because I'm trying to now focus more on just these 3 lines of code here. And in fact, it won't even be 3 lines, it'll just be these 2 lines here, because the get metadata is no longer going to be visible to the outside. So I'm going to define a static method that returns a thumbnailer base. Actually, it's easier to just do this. So what I'm going to do here, I'm going to define a method called create thumbnailer. I'm going to get the ID to create the method for me. Okay, and in here I'm just going to re-implement this. Okay, so what we've done is, now this is not, some people might call this a factory method. It's not, and that's the other confusion, unfortunately, that a factory and factory method are considered to be one and the same method. The factory method pattern, which is part of the Golf book, is not the factory pattern, and nor is this a factory method. This is just a method that creates an instance, And maybe, you know, contextually you could call this a factory method, but as long as there's no confusion that you're saying this is the factory method pattern from the golf book, or this is the factory or whatever, it's not. It's just a method that creates an instance. So what we've done is we've kind of isolated this creation so we can concentrate more on this code here. Right. And here, what if we wanted our users to be able to make a choice of whether they wanted, you know, or maybe they upload a file and it happens to be an image, so we internally make the decision, you know, to create an instance of thumbnail or image or thumbnail or video and so on. Let me change this also to be thumbnail or video. The idea is to, I'm trying to show you that this, which instance to instantiate or create is could be dependent on user choice. And in this case, it's not necessarily user choice, but because the user upload a certain kind of media file, we decide internally to create an instance of thumbnail or A or B. So I'm going to use since this is a console application, I'm just going to use console write line, read line to get the user to provide us with the choice. And this will be console.readline, and we send this choice into this method as a parameter. So this method will have a different behavior based on this choice. In other words, it'll use this choice in a switch case in this case, and let's say if the case is say I for image, or I, in other words, uppercase or lowercase I, we can return a new thumbnail or image, right? While if the case is a V for video or lowercase v, then we can return a new instance of thumbnail or video. Okay, and of course in the case of default here, we should throw a specialized exception in this case when I'm using the base class exception to just say say your choice is invalid or whatever. It doesn't really matter what it is. Of course in this case it doesn't really matter. In your case you should throw a new exception. Okay. This should actually be returning a base class. This should also be a base class. Okay, so this method is always going to return an instance typed as the base class, and the variable here in this case is also typed as a base class. And this is key to being able to use polymorphism. Polymorphism is got these two halves. The one half is a family of classes as we have here. So now we do have a family of classes. We got the thumbnail or base, we got the thumbnail or image, and we got the thumbnail or video. So we have the family of classes, and this is pretty much very obvious to people. You know, you define a family of classes and get some sort of advantage from that. But the other half is how do you use these classes, and that's the key part. We're getting that to our next rule, which is going to be following soon after this. We get this thing to work here, is defining the variable in terms of the base class. Okay, so therefore this method should also be returning instances typed as the base class. No matter what the actual instance may be, it's always typed as the base class. Okay, so we have a way to get a choice. We have to make sure we type in either uppercase or lowercase I, uppercase or lowercase v. In this case we don't have any other options, and then based on that we get an instance. So if I type in I, I'll get an instance of thumbnail or image. If I type in a v, I'll get an instance of thumbnail or video. And this thing is going to call get thumbnail on it, the method thumbnail on it, which is a non-virtual method here in the base class. Let's see the behavior of this. So when I first type in, run it, source code has to be protected, and so does this. then we say does not implement. Can't have this abstract either. Okay, sorry about that. Let's run this. So enter a choice. Let's say I enter I, and what I see here is that even though the get thumbnail went into the base class, as we can see here, when it came time to calling the get metadata, it jumped into the descendant, in this case the image. So what is going on here? How is it able to go from the base class into the descendant, and how does it know the descendant? You know, how does the base class know to call into the descendant and which descendant to call into? And that's where the rule number 2 comes in. And this may be obvious, but I'm giving you the foundational understanding so you understand what's going on. So this is pretty cool as well. The first time I saw this, I like, wow, this is like really weird. Oh my gosh, this is really cool. And then, you know, like recovering from that shock. But I think today things are, you know, people kind of take things for granted. But here it is. Here's how it works. The get thumbnail method is a non-virtual method. We know how non-virtual methods are resolved by the compiler. Non-virtual methods are resolved based on the variable type and at compile time. So it comes in here. Let's just run it. So you'll see what's happening, and then put this here. Virtual methods. Now this method over here happens to be a virtual method, the get metadata. Virtual method resolution is done based on the instance type, which is the instance we instantiate here. It has nothing whatsoever to do with the variable type or the type of this variable. It has completely to do with the instance type. But how does it know in the base what the instance is? And this phenomenon, also called as in polymorphism, is base classes have the ability to reach into descendants. You can imagine this base class here. It has the ability to reach into descendants. Now, it doesn't know the descendants. It couldn't possibly have known of thumbnail, image, and video, and the 15 other descendants you might create in the future. When this class was designed, it had no idea of the descendants that it's going to have. All the descendants certainly know of the base class, but the base class doesn't know about the descendants, and yet the base class is able to reach into descendants of today and in the future. And that's the coolest part about polymorphism. And the way it works is based on the instance type. So I'm going to run this. I'm going to make the same choice here, since I is the only one we've currently tested. And we come into the base classes get thumbnail. That's fine. So far, that's expected because this is a non-virtual method. The variable is typed to be that. I'm going to just collapse this method here. It's going to be typed as a thumbnail or base, so it's going to come to the thumbnail or base. Okay, now from here, how is it, or why is it going into our thumbnail or image? And how does it know to go into our thumbnail or image? That's the key part. How does this class here know to jump into the thumbnail or image? And the reason is that in all object-oriented programming languages, at least the ones I know, instance methods get an intrinsic this parameter or this variable. Now in C# is this, in Delphi it's self, in Python is self, in Java is this, C++ is this. So I'm going to just look at what the this variable is, and if you can see here, the this variable is typed to be, or is an instance of thumbnail or image. And because this is an instance of thumbnail or image, the compiler, so not the compiler, but the way the compiler has written the code is that at runtime, it's going to have to make that decision. Because this is a virtual method, the compiler didn't make the decision at compile time, it deferred the decision to be at runtime. So the way it wrote the code really is what they call virtual method dispatch or dynamic dispatch. At runtime, the code figures out saying, okay, this happens to be an instance of thumbnail or image, so I'm going to shoot into the thumbnail or image. And so when you step in here, it jumps into the thumbnail image. And the reason it's able to do that is because this parameter, this is an intrinsic parameter that's being sent into every instance method in every object. And then the code makes use of that. The code the compiler has generated makes use of this parameter to figure out whether I should be going into thumbnail or image or thumbnail or video or whatever else that may be. So the base class is unaware of the descendants yet because of this decision being made at runtime. we are able to pull off the trick of polymorphism, and that's really how polymorphism works under the hood. So rule number 2, or the mantra number 2, virtual method resolution is based on the instance type. That is the type of the instance that comes back, in this case from this method here. Even though it's typed to be the base, the actual instance happens to be of one of the more of the descendants, and virtual method resolution is done based on the instance type and is done at runtime. In other words, polymorphism is a runtime phenomenon. It's not a design time phenomenon. Just for the sake of testing out, we'll also type in a V here, make sure it goes into the thumbnail or video class. So it comes in here into the base class, step, oops, my mistake, didn't, let's call set next statement, step into, and bang, it comes into the thumbnail or video class. And so this theory has been tested out. Okay, back to the slides. Now, one of the things that was not very clear here is, before I move to the slides, was, inheritance. Now, there are two forms of inheritance. The two forms of inheritance are, one is the implementation reuse kind of inheritance, which is you have a class A, that's your base class, you have a class B. Class B, you want to descend from class A because you want some of the functionality of class A. So you define a new class B, and you want to reuse the functionality of class A and possibly extend class A by descending class B from it. So that's the sort of the way you get reuse for free. That's the one reason for inheritance. The other reason for inheritance is inheritance's ability to define families of objects with identical interfaces. And this is what we're doing here. We're not getting the reuse as much as we do get some of the reuse in terms of this orchestration here, but which is another pattern, by the way, but we will talk about that later. There's one public method here, get thumbnail, and these classes, they're not extending the base class. They're just re-implementing the functionality, in this case, to get metadata of their own choosing. In other words, the behavioral change is coming, in this case, from the get metadata method. So inheritance's ability to define families of objects with identical interfaces, usually by inheriting from an abstract base class as we have over here, and being able to treat them in a uniform fashion. This is key to polymorphism. Polymorphism, in fact, depends on this feature, the ability to define families of objects with identical interfaces. And again, by interfaces, I don't mean, the eye interface. I'm talking about the public surface. So the interface available to this thumbnailer, and the way you can see that is simply by doing dot, and what do you see here? This is the public interface, or the interface of this type, in this case the base class. And because the thumbnailer has been typed to be a base class, the only functionality that we want and can use is the methods we see over here. In this case, our get thumbnail is the method that we've defined, and that is key to polymorphism. In other words, you are always programming to interface, which is a sort of another principle of object-oriented design, is programmed to interface and not implementation. But from the other way to state that is you're writing the code in terms of the base class. This code, you can imagine, 20 lines of code here using the thumbnailer instance, is written in terms of the base class. In other words, you don't care what the instance is. You're always programming to this interface without care for what that instance may be. And the reason for doing that is that you are able to get behavioral difference, as we are seeing over here. Depending on what I type, whether I type I or V, I'm getting different behavior. I'm not changing my code. The client code, in this case, is all called, we always call the client code the code that uses your objects. So barring this method here, we are getting behavioral change by simply creating an instance of a different descendant. And that is what polymorphism is getting behavioral change, calling the same method in this case, and getting behavioral change based on the instance that we are using. Key to polymorphism. So So what are the benefits of manipulating objects solely in terms of the interface defined by the base class? In other words, this is the base class and the interface defined by the base class. Manipulating objects solely in terms of the interface defined by the base class is that the client code, and again the code here, is unaware of the specific types of objects they use. This code has no awareness of what it is it's using. It just knows about the base class. It doesn't know that there's a thumbnail or base, or there's a thumbnail or image or thumbnail or video, or maybe a thumbnail or audio in the future, and so on. It's just completely ignorant of that. And the client code is unaware of the classes that descend from the base class. In other words, this code here has no idea of how many descendants there are, or doesn't care to know either. It's not. Then that's sort of key to writing code that uses polymorphism, is that the client code, is unaware of the descendant. So what we could do here is we could now add define a new class here. Let's call it thumbnail or audio. Right, and make sure this changes to thumbnail audio as well. So far I've just defined a new class. Okay, I'm going to go into this method here, and I'm going to add a new case statement that in the case of an uppercase A and a lowercase a returns to us a thumbnail or audio. Okay, that's all I've done. I've defined a new class and I've come here and made the change. I'm not changing the client code. No changes here. I'm going to simply run this application. At this point I'm going to choose A or lowercase a to see what happens, and what you're going to see, you should probably remove the breakpoints, is that we have behavioral change. What's the behavioral change? It's calling into thumbnail or audios get metadata, yet the client code was not changed. The client code was not aware of thumbnail or audio. It had no idea there was n number of classes, but the behavior was changed, and that is what polymorphism is. The key benefits of polymorphism is, of course, getting behavioral changes depending on the instance, but also the way you write your code is important, because you don't want to have to modify your code over and over in order to get that behavioral change. Okay. And if this is not clear, I'm hoping it's clear, because typically you would have a bunch of if-elses, if-then-elses in your code here to pull this off. And I'm showing you this intentionally so that you don't have a lot of if-then-elses in this code. That's not to say there's no if-then-elses over here, but that's fine. What we're trying to always do is make sure that the main part of your system, the client code, is not cluttered with all the decision making, and it's programming to interface, so it's programming in terms of the base class. Okay. Now we switch over to slides. Okay, so polymorphism. Of the three pillars of object-oriented programming, polymorphism, three pillars being encapsulation, inheritance, and polymorphism. Polymorphism is the cornerstone of object-oriented programming. Without polymorphism, we would have encapsulation and inheritance, which is essentially buckets of data and hierarchical families of buckets of data, but no way to really manipulate related objects in a uniform fashion, which is what we've been doing in our demo code, manipulating related objects in a uniform fashion. By related objects, we mean we're manipulating them in a uniform fashion without having to know of the descendant. We are working with the base class. We don't want to know about the descendants, and yet be able to manipulate these objects in a uniform fashion. Uniform because all of the descendants will have the functionality exposed, in this case the public interface by the base class. That's what polymorphism. That's one way to look at polymorphism. We've already done the demo, so I'm going to reiterate this one more time. Hopefully it's the last time. Virtual method resolution is based on the instance type and is done at runtime. Virtual method resolution is based on the instance type and is done at runtime. The decision of which method to call is being done at runtime. Non-virtual method resolution is based on the variable type and is done at compile time. Okay, these two key, if you can remember these two things and understand how it works, you've got polymorphism. The rest of it is using, or writing the way you write your code, the programming to interface, or writing your code in terms of the base class. So what I have here is essentially the verbatim from the golf book, or the design patterns book by the Gang of Four. And there's a principle they mentioned there called program to an interface, not an implementation. And the rest of it is also verbatim from the golf book. Don't declare variables to be of a particular concrete type, which means in our code here, the variable should not be declared to be a particular concrete type, meaning our thumbnail or image, or thumbnail or video, or thumbnail or audio. And the second is commit only to an interface defined by an abstract base class, which is what we're doing. Our thumbnail or base class is the base class. We're only committing to that interface. Again, interface meaning the public surface or the public interface of that class, the thumbnail or base, right? So these are the two meanings of this principle: program to an interface, not an implementation. So then what is polymorphism? After all that, polymorphism is the use of virtual methods to make one method, and by one method I just mean like this name, get thumbnail, produce one of many possible outcomes or behaviors depending on the instance. So we have one method called get thumbnail. It doesn't have to be only one method, but the idea is to make a method produce one of many possible outcomes or behaviors depending on the instance. So based on the instance, we get different behavior. And polymorphism, this is key. I tell you what, this is key. Almost every design pattern hinges upon this idea. Polymorphism allows ancestors to reach into descendants. And this is what we did over here, which is where we have a base class that has a get metadata method, and at runtime the call goes from the base class into one of the descendants, meaning the base class is able to reach into descendants. You can write your code in such a way, or design your classes in such a way, that code goes from the base class into a descendant even though you don't know what the descendant is. The descendant could be determined at runtime. You could have a plugin architecture that gives you a descendant of your class without you even knowing the class at compile time, but because there's an assembly that was found that has a descendant of your class, you can use that class at that moment in time without knowing what the descendant was. Right, so that's a key feature, being able to reach into descendants. That's one way to look at it, reach into descendants, so you can understand polymorphism better. So at this point, I hopefully have accomplished my goal of giving you a clear foundational understanding of polymorphism. In part 2, we'll be looking at refactoring this code a bit more and making it a little more real world. It's going to get a little more complicated in terms of the implementations of things, but I'm hoping that because you see it being used in a more real world fashion, things will get a little more sort of carved in stone in your minds. So take a look at part 2, which basically is an extension of all the code base we have here, but make an application that has some visual outcomes, so you can get a better sense of what's happening behind the scenes. So thank you for watching, and see you in the next episode.